See here. What is conditional probability? Come on, tell me. Suppose E is an event. I want to find the probability given that F has already happened. Then what will be P of E given F, Jerome?
P of E intersection F by P of F. Sir.
Excellent. Okay. Now, Ranika, can you tell me what is P of F intersection E?
Yes.
F given E? What is P of F intersection E?
Sir, it is P of F intersection E by P of E, sir.
Correct. Is it okay to write F intersection E as E intersection F, Ranika?
Yes, sir.
Yeah. Okay, now you just observe. Jerome, if I just cross multiply this, I take this F this side, right? Then what will it be? What will be P of E intersection F?
P of E given F into P of F. Sir.
Or I can write it as P of F into P of E given F. Correct, Jerome?
Yes, sir.
Yeah. Ranika, can you tell me when I take this P of E that side, how can I write P of E intersection F?
Sir, it is P of E into P of F by E. F
F
given
given E, you don't say F by E, you'll say what?
E. Yes. F given E. Sir.
Exactly. So this is called multiplication theorem in probability. And make a note of this. Okay, have you taken down? Okay. In fact, this concept we have seen in permutations combinations itself last year, right? Whenever there is AND or intersection, you're going to multiply, correct? So that's what we are doing here. When I say P of E intersection F, that means event E is happening and F is happening. So whenever I have this AND, right, I'm going to multiply. So if E happens first, it is like P of E into P of F, given that E has already happened. Suppose if F happens, right, then it is P of F into P of E, given that F has already happened, right? So that is what is called as multiplication theorem in probability. You can see P of E intersection F, how can we write? P of F into P of E given F, or P of E into P of F given E, correct? Right. Okay, now let's solve a few questions. Okay. So this rule is known as multiplication theorem in probability. Okay, so let's look into this question now. Okay. If P of A is 3 by 5, P of B is 1 by 5, find P of A intersection B if A and B are independent events. Right? Okay. Now I'm going to tell you what happens when two events are independent, right? Okay. Now, if A and B are independent, if A and B are independent events, then can you tell me, Jerome, how can I write P of A given B? Not as the formula. Huh? Formula you know very well. What is P of A given B?
The formula, sir.
A formula you tell me?
P of A intersection B by P of B, sir.
Correct, correct. So I don't want the formula right now as a concept, right? P of A given that B has already happened, right? I will give you one example, okay, Jerome? Suppose let's say you have a pack of cards. Now, you know how many king cards are there, Jerome?
Uh,
Totally 52 cards are there. King, how many will be there?
26, sir.
No, no. Ranika, can you unmute?
Four, sir.
Correct. See here, how many red cards are there, Ranika?
Red cards are 26.
Yes, black cards.
26.
And how many heart cards are there?
13.
Yes. How many diamond cards are there?
13.
Are you listening, Jerome?
Yes, sir.
Yeah. How many club cards are there?
13.
Yes, right. So you have 13 of different varieties, right? How many uh, club or claver you can say, and the other one is spade. How many spades are there?
That also 13.
Correct. Okay. And how many king cards are there?
4.
How many queen cards are there?
4.
How many jack?
4.
And how many red kings?
Red kings would be 2, sir.
Very good. How many black kings?
2, sir.
Very good. How many heart kings?
Heart king 1, sir.
One. Excellent. Very good. Jerome, are you understanding, Jerome?
Yes, sir.
Totally how many cards, Jerome?
52, sir.
Right. What is the, how many red cards we have?
26, sir.
26. How many black cards?
26.
Correct. How many kings?
4, sir.
Yes. Okay, fine. So now I'm going to ask you. So I'm going to pick a king card. What is the probability of picking a king card from a pack of 52 cards?
4 by 52, sir.
Very good. Excellent. 4 by 52. Correct. Okay, let's say I picked a king card and kept it aside. Now I'm going to pick a queen card. Okay. Now I'm going to pick a queen card given that a king was picked earlier. Correct. Can you tell me what is the probability of drawing a queen card now?
Four by 52, sir.
I took the king card, kept it aside. How many cards are there now, Jerome?
So 52 minus 4, sir.
Why 4? I just took one king card, no?
So 52 minus 1.
Yeah, 51 cards are only there, no? Just visualize. You had 52 cards, one card I have taken away, and that card is king. So how many cards are remaining now? What, Jerome? You had 52 apples, one apple you have eaten. How many apples are remaining?
51, sir.
Why are you thinking? So you have taken the king card away. So how many cards are total cards are there now?
51, sir.
Yes. Now how many queens are there in that card?
4, sir.
Yeah. So what is the probability of drawing a queen now?
4 by 51.
That's all. Is it clear or not?
Yes, sir.
Okay. So what is this question? What is the probability of drawing a queen given that a king was drawn before and kept aside? Correct. So what is the probability now?
4 by 51.
Do you understand?
Yes, sir.
So the drawing activity of queen right now depended on the previous outcome. Yes or no?
Yes, sir.
Instead of drawing a king in the previous stage, now Ranika, I will ask you a question.
Yes, sir.
Yeah. So I have drawn a queen card first, okay?
Okay,
So
sir.
what would have been that probability, Ranika?
It would be 4 by 52, sir.
Correct? Okay. I have taken that queen card and kept it aside. Now, what is the probability of drawing a queen card given that a queen card was taken earlier and kept aside?
3 by 51, sir.
Excellent answer. Very good, right? Because now Jerome, can you justify your answer? First, what did I take out?
First you took out a king, sir.
Not king. Now, new question. Listen carefully. I took out a queen card. Queen. So, what was the probability of that?
4 by 52.
Yeah, now I took that queen card, kept it aside. Now, my question is, what is the probability of drawing a queen given that a queen was taken earlier and kept aside?
4 by 51.
Already I draw a queen, ma.
So 3 by 51.
Yes, that's what she answered. Do you remember? Do you understand now?
Yes, sir.
Yeah, very good. So the previous outcome impacted the present outcome or not?
Yes, sir.
Yeah, so such events are called dependent events, correct? Is it clear now?
Yes, sir.
Okay, now we are talking about independent events. So what are two, when do you say two events are independent? When the outcome of the present event does not depend on when the outcome of the present event does not depend on the previous outcome. I will give you one example now. Same question, slight change I will do. First time I had drawn a king card. What is the probability of drawing that king card, Jerome?
4 by 52.
Correct, right? Now I have replaced it back in the deck. Now I am going to draw another king. What is the probability of drawing king now, given that a king was drawn earlier and kept back?
Will it be same, sir?
It will be same, isn't it?
Yes,
Won't it be 4 by 52 now?
yes, sir.
Whether is it not? Correct, Jerome?
Yes, sir.
Very good. Now, in the first case, I took a queen out, okay? What is the probability of drawing a queen first?
4 by 52.
Yeah, now I replaced it back in the deck. Now, what is the probability of drawing a queen, given that I had drawn a queen earlier?
4 by 52.
4 by 52 only, because I have replaced the card back, correct? So such events. Now, in this case, the two events are dependent or independent?
Independent, sir.
Independent, correct? Very good. Now you understood what is independent. When are two events independent, correct? So, can you tell me, Jerome, if I say P of A given B, that means what is the probability of A given that B has already happened? What do you expect it to be, Jerome? Not as a formula, but just as a logic. For example, I am drawing a king now. Given that a queen was already taken, what would that probability be if they were independent?
4 by 52.
That means what was it? What is it? What is it?
Independence.
Correct, my independent. So P of K given Q, that means probability of drawing a king. Given that a queen was drawn, how can I write it in words? Of course, 4 by 52 answer is correct. If I have to write it in symbol, how will you write it?
Uh, P of K given
K given Q is what is on the left hand side. Whether that given Q matters or not does not matter.
does not matter, sir.
Then what does it become?
P of K.
Excellent. Very good. It becomes P of K itself. Do you agree this, Ranika? Agree to this, Ranika?
Yes, sir.
Yes, very much. So what will be P of A given B? What is it going to be? P of A, given that B has already happened, will be nothing but Jerome?
P of A, sir.
Very good. Excellent. Ranika, do you agree to this?
Yes, sir.
Excellent. So can you tell me, Ranika, if P of B given B, how can I write it? Sorry, B given A.
It is P of B, sir.
Very good. Excellent. That's all. So now, sorry. Excellent. So now two events are said to be independent if P of A given B is nothing but what? Yes, Jerome, P of A given B is nothing but
P of A, sir.
And P of B given A is?
P of B.
Correct. Now let's go back to the formula which we discussed, right? From multiplication theorem, what was the formula for P of A intersection B? What was the formula for P of A intersection B? Yeah, go ahead, Jerome.
P of B cross
P
P
of
of
to
A given B.
A given B. Very good, very good, very good. Now tell me, Jerome, if A and B are independent, then what will happen to P of A given B?
Uh, P of A, sir.
Yes. So P of A intersection B simply becomes what?
P of B into P of A.
Very good. Then the two events are independent. Are you clear?
Yes, sir.
Yes, Ranika, can you tell me the other form of multiplication theorem? P of A intersection B can be written as what?
So the normal formula, sir.
Normal formula first tell me.
So it is a P of B into P of A given B.
Okay, that Jerome has told. Can you write it in any other way, Ranika?
P
Is
of
it you noted
P
it
of
down?
B into P of A, sir.
No, that is correct. Huh? I'm just asking you, is there any other way of writing P of A intersection B? There are two forms in which we write no. You noted down two
So
forms.
N of B by N of S into.
Not that level. See, not that. You can write P of A intersection B as P of B into P of A given B, or what is the other form? P of A into P of B given A. Have you seen this or not, Radhika?
Yes, sir.
Yeah, that is what I was asking. So now tell me, you noted it down, Radhika?
I'll note it down also. 1 minute.
So P of A intersection B can be written in two ways, right?
Yes, sir.
Yeah. So what? How can I write P of A intersection B?
P of A into P of B, sir.
P of B given A is one form. Another form is what? P of B into
P of A given B, sir.
correct. Okay. Now you come to if A and B are independent, then what will happen to the second term, Ranika?
Then the second term would be P of B, sir.
That's all. That's all. Very good. Therefore, in either case, you can see that P of A intersection B is what? P of A into. In either case, P of A intersection B is P of A into P of B, right? Please keep yourself unmute. No?
Yes, sir.
Yeah, that's all. So please take down. If A and B are independent, P of A intersection B. What is P of A intersection B? It's simply P of A into P of B. Make a note of it. What Aditya, have not connected your video. Okay, ma. So once again, I repeat, if A and B are independent events, what is P of A intersection B, Jerome?
P of B into P of A, sir.
P of A into
P of A into P of B, sir.
right, or P of B into P of A, doesn't matter. Yes, Ranika, if A and B are independent, what is P of A intersection B?
P of A into P of B, sir.
That's all. That's all. Now with this knowledge, can you try the first question? So this exercise is a very, very simple exercise. Okay. It is an entire exercise based on this idea only. So A and B are independent events. P of A is given, P of B is given. You need to find P of A intersection B. So what is P of A intersection B given by if A and B are independent? Yes, Jerome. What is P of A intersection B?
P of B into P of A, sir.
Yeah, or P of A into P of B, right? Both are given, right? So what is P of A?
3 by 5.
What is P of B?
1 by 5.
Therefore, what is P of A intersection B?
3 by 25.
That's all. Are you getting the same answer, Anika?
Yes, sir.
Yes, very good. Now let's move on to the next question.
Sir, one doubt, sir.
Please tell me, Jerome.
Sir, we can write in both ways, sir.
Both are same, no?
We can write P of B into A or P of A into
Yeah,
B.
whether it is 3 by 5 into 1 by 5 or 1 by 5 into 3 by 5, you get the same answer.
Okay.
Correct. Okay, next one. Yes, Anika, can you try answering this question now? Good, good, Aditya. Yeah. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Correct? So what is the first event, Ranika?
So the first event is the cards are black, sir. Two cards are drawn, sir.
Two cards are drawn. No, let's E be the first outcome. F be the second outcome. Correct?
Yes, sir.
The first card drawn is what?
It's black, sir.
And what about the second event?
That card is also black, sir.
Exactly. Second card drawn is also black, isn't it?
Yes.
Okay. Now, it is without replacement, correct, Ranika?
Yes, sir.
So what do you expect these two events to be? Will they be independent or dependent?
It will be dependent.
Very good, very good. It will be dependent, correct? So can you tell me what is the probability of the first event?
26 by 52, sir.
Very good. Because there are 26 black cards, totally there are 52 cards. Very good. Now when you write P of this one, right, you should write it as what? P of F given E, correct?
Yes, sir.
What is the probability that the second card is black, given that the first card was black? So what is your answer going to be?
25 by 51, sir.
Excellent, 25 by 51, right? But what is asked here is, find the probability that both the cards are black, which means the first card should be black and the second card should also be black. Did you understand?
Yes, sir.
So they are asking for P of E intersection F.
Intersection.
So how do you write P of E intersection F, Ranika?
P of E into P of F, sir.
Not P of E into P of F. That is only if the two events are independent.
Oh, sorry, sir. P of E into P of E F given E, sir.
So repeat again.
P of E intersection F is equal to P of E into P of F given E.
Very good. Very good. Basically, you have to multiply these two probabilities. That's all.
Yes.
So what is it? 26 by 52 multiplied by 25 by 51. Have you been observing, Jerome?
Sir, I didn't understand where how is it dependent, sir?
Okay, I'll come to that. So it is 1 by 2. So answer is 25 by 1 not. So final answer is 25 by 1 not. Jerome, unmute and listen carefully. We discussed two examples last time, right? I draw a king, keep it aside, and then I'm going to draw a queen. What is the probability of drawing a queen when I took a king earlier?
4 by 51.
4 by 51, correct? So I had taken king earlier outside, right? So did that affect this probability or not?
It did, sir.
It did, right?
Yes, sir.
So are these two events dependent or independent?
Dependent, sir.
Correct. So whenever you do the experiment without replacement of the cards, which means you took the card and kept it aside, you didn't keep it back, then events will become
Dependent.
dependent. Correct. See here, you can clearly see. First time when she is drawing the card, black card, what is the probability, Jerome?
26 by 50.
Now a black card is taken and kept aside. So how many black cards are remaining now?
So 25 by 51.
So 25 black cards are there. Total cards is 51. Understood?
Yes, sir.
So are you clear now when you are getting two events to be dependent?
Yes, sir.
When would they be independent?
When they are replaced, sir.
Exactly. If I replace it back in the deck, then it will become independent. Are you clear now?
Yes, sir.
Yeah. Okay, let's move on. Have you noted down this, Aditya? Taken down? Okay. Okay, let's move on to the next question now. Jerome, you've taken down this question.
Yes, sir. Done.
Okay. So you can see. So the answer is 25 by 102. Let's move on to the next question. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box is approved for sale. Otherwise, it is rejected. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad, will be approved for sale. So how many oranges are there? Totally 15 oranges. Out of which how many are good? 12 are good. How many are bad? 3 are bad. Now, whether this box will be approved or not, it depends on you are going to select 3 randomly, 3 oranges randomly. And if all those 3 are good, then you will approve it for sale. So here, although there are 3 bad ones in this lot and 12 good ones, it is given that it is approved for sale. So this particular box is approved for sale. For that, what is the probability? Correct. Did you understand the question? So you have a box, 12 good oranges are there, 3 bad oranges are there. Totally you have 15 oranges in this box. Correct? Now you are going to randomly pull out 3 oranges. It is given that it is approved for sale. That means all the 3 oranges which you took out, were good or bad? Yes, Jerome, please unmute.
Bad, sir.
If it is bad, means will it be approved for sale?
No, sir.
See here, he is examining 3 oranges without replacement. If all the 3 oranges are good, then the box is approved for sale. Correct or not? So if this box is approved for sale, how many oranges he is taking out?
3, sir.
3. And none of them is bad. Correct or not? If all those 3 oranges are good, then it is approved for sale. Clear or not?
Yes, sir.
So here, because it is approved for sale, all the 3 oranges he took must be what?
Good, sir.
Good. Exactly. Is it clear? So first orange he takes, that is good. Second orange he takes, that is also what? Good. The third orange he takes, that is also good. Therefore, the box is approved for sale. Correct? So what is the probability for that? So first orange is good. And the second orange is good. And the third orange is also good. Correct? What is the probability for first orange to be good? Can you tell me the probability, Jerome?
1 by 15, sir.
1 by 15, where did that 1 come from? Remember, recall this. King card, how many cards are there totally? 52.
52.
You want to draw one king card. What is the probability?
4, sir.
4 by?
52.
Now come back to this sum. How many oranges are there?
15.
How many good oranges are there?
12, sir.
How many bad oranges are there?
3.
What is the probability of taking out a good orange?
12 by 15.
Very good. Now you understood?
Yes, sir.
So probability of first orange being good is what? 12 by 15. Now what do you do? Do you replace that orange back in the box or you keep it aside?
Keep it aside, sir.
Yeah. How do you know that?
Without replacement.
Exactly. Right. Now tell me how many good oranges are there in the box?
11, sir.
How many total oranges are there?
14.
What is the probability of drawing a good orange now?
11 by 14.
Very good. Now you took one more orange now, correct? Which is good. And you kept it aside. Now how many oranges you have taken out totally?
13, sir.
How many oranges you have taken out totally?
10.
Have you taken 10 oranges totally out?
2 oranges, sir.
Yes, 2 oranges you have taken out. So how many oranges are remaining?
10, sir.
No, how many total number of oranges are remaining?
13.
Yeah, how many good oranges are remaining?
10.
Yeah, so what is the probability of drawing the third good orange?
10 by 13.
Yes, that's all. Is it clear now? Is it clear?
Yes, sir.
That's all. So that's going to be the answer. So this is 4 into 3. This is 5 into 3. Again 5 and 10 I can cancel 2 times. 2 and 14, 7 times. So 4 into 11, 44. 13 into 7, 91. So answer is 44 by 91. Did you understand, Jerome?
Yes, sir.
Is it clear, Anika?
Yes, sir.
Aditya, is it clear? Okay. So 44 by 91 is the correct answer. Can we go on to the next question? Have you taken this down? Okay. Yes, Ranika, can you unmute and tell me what are these two events? What is event A?
So event A is tossing of coins. It
No, event A is head appears on the coin.
appears on the coin.
Okay, what is event B?
3 on the dice.
3 on the die. Logically tell me, Ranika, are these even without solving anything? Can you say whether these two events are dependent or independent?
They are independent.
Independent, correct? Now let us prove it, correct? Because what comes on a die doesn't matter, doesn't depend on what came on the toss, correct?
Yes, sir.
Yes. But anyways, we will prove it now. So can you tell me what is the probability of A, Ranika?
A is 1 by 2, sir.
Correct. What is the probability that 3 occurred on the die given that that coin was tossed, head appeared?
1 by 6, sir.
1 by 6, it doesn't matter, right?
Yes, sir.
Exactly. So you can clearly see. And what is the probability of getting a head and getting a 3 on the die?
P of A intersection B.
That's nothing but P of A into,
P of B given is
which is nothing but 1 by 2 into 1 by 6, which is
1 by 12.
correct. No, which
Yes,
is
sir.
nothing but P of A into P of B itself.
Yes, sir.
Because P of B will be what? Getting a 3 on the die, which is what?
1 by 6.
Hence the proof. So these two are what? Basically, they are what?
Independent events.
Yeah. So A and B are independent events. That's the conclusion. Any doubts in this, Jerome?
No, sir.
Is it clear? What about you, Aditya? Clear? Okay. Shall we move on to the next question? Have you noted down? So we can see the two events are independent. It is not necessary to write the sample space completely and then right. The way we did it, that is also sufficient. Or you want to be like this, right? So I hope you can understand. If you're tossing a coin and a die, then you can see, right? You can do it this way too. See, when you toss a coin, what are the outcomes? Head and tail, right? Head or tail. When you throw a die, what are the outcomes? 1, 2, 3, 4, 5, 6. So what will be the entire sample space? H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Head appears on the coin. Head appears on the coin means what? These 6. So 6 by 12, correct? That will be 1 by 2. Head appears on the first one and 3 appears on the die. That means only H comma 3. What is probability of H comma 3? 1 by 6, correct? Yes or no? 1 second, ma. Getting a 3. Getting a 3 appearing on dice means these two outcomes are there. H comma 3, T comma 3. So you'll get 2 by 12, 1 by 6. But head on the first and 3 on the second means only this. Only this. Therefore, P of A intersection will be 12. And P of B means what? 3 appearing on the die. That means this one and this one. Both will come, therefore 2 by 12. Head on the coin means all these 6 will come. So you will get 6 by 12. Correct? So you can clearly see P of A intersection B is 1 by 12. P of A into P of B is what? 1 by 2 into 1 by 6, which is also 1 by 12. Therefore, I can clearly say that A and B are independent. Did you understand this method? Yes, Ranika?
Yes, sir.
Yes. Jerome, any doubts?
No, sir.
Are you clear?
Yes, sir.
Okay. Aditya? Okay. So we will move on to the next question. Given that the events A and B are such that P of A is 1 by 2, P of A union B is 3 by 5, and P of B we don't know. Let's say it's P. First part, find P if they are mutually exclusive. What do you mean by mutually exclusive? We have learned last year. Two events A and B are mutually exclusive if the occurrence of one prevents the occurrence of other. Okay, what is the meaning of mutually exclusive? Occurrence of one event prevents the occurrence of other. Can you give me an example for two events which are mutually exclusive? Yes, Ranika?
So, like you gave in a deck of cards, if the king is taken and without replacement, another queen is taken, sir.
No. This is not about. See, here both are possible, no? First you are taking a king, then you are taking a queen. Both are possible, right? Those are dependent, independent events. I'm asking about mutually exclusive. The occurrence of one event will prevent the occurrence of other. See here, for example, in US election, let's say Donald Trump and Kamala Harris were competing, right? If Donald Trump becomes the president, can Kamala Harris also become the president? Tell me yes or no.
No, sir.
No, right? So the occurrence of one event prevents the occurrence of the other event. So mathematically, what is that you should know? If A and B are mutually exclusive, P of A intersection B is 0. You have seen this last year. Tanika, can you tell me what is the meaning of A intersection B?
So, the possibility of A and B occurring together is 0.
Exactly. A intersection B means A and B. There is no possibility of A and B occurring together, both of them happening. Only one of them can happen, correct? So the
Yes, sir.
probability of A intersection B is 0 for mutually exclusive events. Okay. Now, we have P of A union B, right? Can you tell me the formula for P of A union B? Yes, Jerome?
P of A plus P of B minus P of A intersection B.
Correct. But because the two events are mutually exclusive, what will happen to the third term, Jerome?
It becomes 0, sir.
Very good. So you will have only P of A union B as P of A plus P of B. Now P of A union B, you are already given the number. What is it?
3 by 5.
And P of A also you are given the number. What is it?
1 by 2.
And P of B you need to find. You are taking it as what? P. So just calculate this. So P will be equal to 3 divided by 5 minus 1 by 2. If you take LCM, it's 10. So 3 into 2, 6. 1 into 5, 5. So what is the answer for P of B, Jerome?
1 by 10. Sir.
Yes. Is it clear, Ranika?
Yes, sir.
Aditya? Okay. So first part we have answered now. Second part you have learned it today. Find the P of B if A and B are independent. I hope you have noted down this. Let's do the second part now. Given that the events A and B are such that P of A is 1 by 2, P of A union B is 3 by 5, P of B is P, find P if they are independent. Yes, Ranika, can you tell me? When I say that A and B are independent, what is the meaning?
P of A intersection B is equal to P of A into P of B, sir.
Very good. P of A intersection B is equal to P of A into P of B. Here, do we know P of A intersection B directly, Ranika?
No, sir.
Yeah, but can we find?
Yes, sir.
What is the formula for P of A union B?
It's P of A plus P of B minus P of A intersection B, sir.
Correct. Now, what is P of A union B?
3 by 5, sir.
Yes. What is P of A?
1 by 2.
What is P of B?
P, sir.
P. And P of A intersection B, I don't know at this time, right? So P of A intersection B, will take it to this side. Will be equal to what? 1 by 2 plus P minus 3 by 5. Correct, Ranika?
Yes, sir.
Okay. So in place of P of A intersection B, what can I write? In place of P of A intersection B, what can I write? 1 by 2 plus, please unmute.
Yes, sir.
What can I write in place of P of A intersection B?
Half plus P minus 3 by 5, sir.
Right. Correct. On the right hand side, what is P of A, Ranika?
1 by 2, sir.
And what is P of B?
P, sir.
Yes. So now what I can do, I have equation only in one variable, so it's easy to solve. So this half P, I can take it to this side. This is minus 3 by 5 and 1 by 2, I can bring it to this side. So what do you get, Ranika? P minus 1 by 2P is equal to?
Do 1 by 10, sir.
Right. 3 by 5 minus 1 by 2, right? So what is P minus P by 2? P by 2. And this will be 6 minus 5 by 1 by 10. So what is your P equal to?
P is equal to 5, sir.
No. 2 by 10.
2 by 1
1
by
by
5.
5. The answer can never be greater than 1, correct?
Yes.
So answer is 1 by 5. Is it clear now, Ranika?
Yes, sir.
Yes. Is it clear, Jerome? Are you getting the same?
Yes, sir.
Aditya? Okay. So you can see here. So the first part, the answer was 1 by 10. Second part, the answer is 1 by 5. That's what we got. Any doubts in this? You can note it down. Once you're done, then we'll move on to the next. Okay, shall we move on to the next one? Are you all ready? Okay. 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 Let A and B be two independent events with P of A 0.3, P of B 0.4. Find the following. Very simple question. It is given that the two events are independent. Jerome, when two events are independent, what is P of A intersection B, Jerome?
P of A into P of B, sir.
Very good. So what is P of A?
0.3.
And what is P of B?
0.4.
This will be nothing but 0.12. So what is your P of A intersection B? 0.12. What is the next thing you need to find, Jerome?
P of A union B.
What is the formula for P of A union B?
P of A plus P of B into minus P of A minus A intersection B.
Correct. So what is P of A?
0.3.
What is P of B?
0.4.
What is P of A intersection B?
0.12.
Exactly. So 0.3 plus 0.4 is 0.7. 0.7 minus 0.12 will be 0.58, correct? 58 plus 12 is 72. 70, right? Are you getting the same answer, Anika?
Yes, sir.
Aditya? Okay. Next one. P of A given B. What is the formula for P of A given B, Anika?
Sir, it is P of A intersection B by P of A, sir.
Sorry?
P of A intersection B by P of B, sir.
Yes, you have to be careful about that, Anika. So it's P of A intersection B by P of B. So what is it going to be? What is P of A intersection B?
0.12 by 0.4, sir.
So what is the answer?
0.3, sir.
Is there any other way you could have done this, Ranika? Because it is given that A and B are independent, then what will be P of A given B? P of A given B will be simply P of A, no?
Yes, sir.
So it will be just 0.3, no? Can you answer the next one based on that? What is P of B given A going to be, Ranika?
It's going to be P of B, sir.
Because that A happened does not matter, right?
Yes, sir.
What is P of B?
0.4.
That's even if you substitute in the formula, you're going to get the same thing. Is it clear?
Yes, sir.
Yes, very good. Have you noted down, Aditya, Jerome? First answer is 0.12, next is 0.58, next 0.3, 0.4. Let's verify. Yeah, 0.12 is the first answer, then 0.58, and 0.3 and 0.4. Okay, we'll do one more question and sign off for the day. Okay, in a girls' hostel, 60% of the students read Hindi newspaper, 40% read English newspaper, and 20% read both English and Hindi newspapers. A student is selected at random. First question, find the probability she reads neither Hindi nor English. Second one, if she reads Hindi newspaper, find the probability that she reads English newspaper. And C is, if she reads English newspaper, find the probability she reads Hindi newspaper. Okay. So here, if you remember in sets, you would have done some word problems based on this, right? Based on Venn diagram, you would have learned, correct? So let's say this refers to Hindi newspaper, and let's say the circle refers to English newspaper, correct? 60% read Hindi newspaper. So probability that a selected girl will read Hindi newspaper is 60%. That is nothing but 60 divided by 100. Or I can say 6 by 10 or 3 by 5. Probability that a selected student will read English newspaper is 40%. Which means it's 40 by 100 or 4 by 10 or 2 by 5. A selected girl reads both English and Hindi newspaper, and means intersection. So that is 20%. 20% is nothing but 20 by 100, or I can write it as 1 by 5. Correct? Now all this information we have, correct? Now we need to find out what is the probability that she reads neither, a student selected randomly reads neither Hindi nor English, right? Okay, now tell me more. Neither Hindi means what? How can I write it in word, in symbols? Can I write it as H bar or H dash? What is H? Reading Hindi. H bar means what? Not reading Hindi. Understood or not? Or H dash. And not English also. So neither Hindi nor English means H bar and E bar. Or in other words, I can write P of H bar, or I can write H dash intersection E dash, right? Because and refers to what? Intersection. This means what? The student neither reads Hindi paper nor English paper. Is it clear, Ranika?
Yes, sir.
What about Jerome?
Yes, sir.
Aditya? Okay. Do you remember something called De Morgan's law, which you have learned in your first year? How do you write A dash intersection B dash? How do you write it? Is it not A union B the whole dash? Yes or no? So P of H dash intersection E dash, I can write it as P of H union E, the whole dash. Using De Morgan's law. And how can you write P of H union E, the whole dash? Here in probability, you know, P of A plus P of A dash. What is it? Tanika, can you unmute?
Yes, sir.
What is probability of occurrence of an event plus probability of non-occurrence of an event? What is the value? Is it not 1?
Yes, sir.
Either A should happen or A bar should happen. Correct or not?
Yes, sir.
Yeah, one of them will definitely happen. Therefore, it's a sure event. P of A plus P of A dash is equal to 1. So how can I write P of A dash?
1 minus P of A.
Correct? You must have done this in your 11th as well, right? Similarly, P of H union E, the whole dash, can be written as 1 minus P of H union E. Is it correct, Ranika?
Yes, sir.
Yes. So now our goal is to find P of H union E. Yes, Jerome, how do you find P of H union E?
P of H plus P of E minus P of H intersection.
Very good. And all those informations are with you. What is P of H?
3 by 5.
50%. What is English? 40%. What is Hindi and English?
20.
So what is answer?
80.
80 by 100. Correct or not? Or this you can write it as what? 4 by 5. So it is 1 minus 4 by 5. So what is 1 minus 4 by 5? 1 by 5. Therefore, the correct answer for the first part of the question is 1 by 5, or you can write it as 0.2. Is it clear, Ranika?
Yes, sir.
Jerome? Please.
Yes.
Yes, Aditya? Okay. Please take down. So first answer is 1 by 5. Let's verify. First answer you can see is 1 by 5. Second and third are straightforward. Very, very simple. Ranika, can you convert this into symbols? If she reads Hindi newspaper, what is the probability that she reads English newspaper? How do you write it? What event is already happened?
She reads Hindi newspapers, sir.
That has already happened. Now what do you need to find, Ranika?
If she reads English newspaper.
Find the probability that she reads English newspaper, correct?
P of E given H, sir.
Excellent, excellent. Very, very good, right? So you need to find the probability that she reads English newspaper, given that she reads Hindi newspaper. That's all. Did you understand this, Jerome?
Yes, sir.
That's all. This formula, you know. What is the formula, Ranika?
P of E intersection H by P of H, sir.
Divided by P of H. What is P of E intersection H?
20.
20%. What is P of H?
60%.
That's all. So what is your answer?
1 by 3, sir.
That's all. Is it clear, Ranika?
Yes, sir.
Yes. Is it clear, Jerome?
Yes, sir.
Aditya, clear? So the next answer is 1 by 3. Let's verify. So next answer is 1 by 3. Jerome, let's do the final part. just erasing the diagram and then we'll do this here. C part. Tell me, Jerome. What is given? What is asked? What is asked actually?
Probability of she reading Hindi news.
Probability that she reads in the newspaper. What is given?
English newspaper.
So what you are supposed to find?
Hindi newspaper.
No, write it in symbol. Tell me, ma.
P of H given E, sir.
Like that you should say. Because simply if you say Hindi newspaper, that is already given. 60% read Hindi, correct? So what you should do? You have to probability of H given.
E, sir.
Yes. So what is the formula for this?
P of E intersection H by P of E, sir.
Very good. And what is P of E intersection H, Jerome?
20 by 100.
Yeah, 20 by 100. What is P of E?
2 by 5.
Yeah, or 40% is easy, no? So 100 you can cancel. 20 by 40. What is 20 by 40?
1 by 2.
That's all. That's the third answer. You can see here 1 by 2 is the third answer. Is it clear, Jerome? What about Ranika?
Yes, sir.
Very good. Aditya? Okay. If you have noted down, I think with that we will conclude today's class. Okay.